Namaste dosto. Have you ever wondered how we can measure the spread of a bunch of numbers, like your cricket scores or your marks in different tests? Today, we'll explore a concept called mean deviation, which helps us understand how data points spread out from a central value. Think of it like measuring how far your friends sit from the center of a round table, some close, some a little further. So, what exactly is mean deviation? Simply put, it's the average of how far each data point is from a central value, like the mean or median of the data. Here's the formula you'll often see. Mean deviation equals 1 divided by n multiplied by the sum of the absolute values of x sub I minus a, where a could be the mean or the median. In words, that's the sum of the absolute differences between each data point and the chosen center divided by the total number of points. Important thing to note, mean deviation is always 0 or positive because we take absolute differences, so no positive and negative values cancel out. This absolute value step ensures we are looking at pure distances, not direction. Why does that matter? Because it gives us a clear picture of the average distance from the center, telling us about the consistency or variability in the data. Imagine if all your test marks are close to the average, the mean deviation would be low, showing less spread. But if the marks vary a lot, the mean deviation would be higher, signaling more inconsistency. So, by calculating mean deviation, we get a practical tool to measure how spread out our data is around a central point. Ready to dig deeper and see how to calculate it? Let's move on. Let's now learn how to compute mean deviation about the mean, starting with ungrouped data, that is, raw data without any categorization. First, we calculate the mean, noted as x bar, which is just the sum of all the data points divided by the number of points. So, x bar equals 1 over n times the sum of x sub I. Next, for each data point, we find the deviation from the mean. But here's the twist. Instead of just subtracting, we take the absolute value. That means ignoring whether the difference is positive or negative. So for each x sub I, calculate the absolute value of x sub I minus x bar. Then, add all these absolute deviations together. Finally, divide this total by the number of data points to get the mean deviation about the mean. In other words, mean deviation equals 1 over n times the sum of the absolute values of x sub I minus x bar. One interesting point, for datasets that are skewed, where values bunch more on one side than the other, the mean deviation calculated about the median gives a smaller value, meaning median sometimes better represents the center. Imagine a table showing these steps: data values, their deviation from the mean, and the absolute deviations next to them. It helps visualize how spread is calculated. Remember, this process helps us see how much, on average, our data points deviate from the mean, giving insight into variability. Now, let's talk about mean deviation about the median, a powerful alternative especially when dealing with skewed data. In distributions where the data isn't symmetrical, the median often gives a better sense of the center than the mean. This is because median is less affected by extreme values or outliers. The formula here is similar to what we've seen. Mean deviation about the median equals 1 over n times the sum of the absolute values of x sub I minus m, where m is the median. Taking deviations from the median rather than the mean reduces the influence of outliers. The extreme values don't pull the center as much. Picture a number line with data points arranged in order, highlighting the median in the middle. Then, vertical lines from each data point down to the median represent their absolute deviations. This visual helps understand how spread is calculated about median. So, when your data has outliers, say, one unusually high test score, the mean deviation about median better reflects the true variability in your dataset. Up next, how do we handle mean deviation when the data is grouped, like marks grouped in class intervals with frequencies? For frequency distributions, the mean deviation weighs the deviations by how often each value occurs. That is, by frequencies. The formula becomes mean deviation equals the sum over I of the frequency f sub I multiplied by the absolute value of x sub I minus a, divided by the sum of all frequencies. Here, X sub I is typically the class mark or midpoint of a class interval, and A is the central value, either the mean or the median. Steps are straightforward. Calculate the mean first, which is the sum of frequency times class mark over total frequencies. Next, find the deviations of each class mark from the mean. Take their absolute values, multiply each by the frequency of that class, and then add these all up. Divide this total by the sum of all frequencies to get the mean deviation. Absolute values are crucial. They ensure that large positive and negative deviations don't cancel out, giving a true measure of spread. Visualize a frequency table with columns for class marks, frequencies, deviations, absolute deviations, and frequency times absolute deviations. This table simplifies the calculation process. This method helps us understand variation in group data like exam marks distributed over intervals. Now, let's see a solved example with ungrouped data to make it crystal clear. Given the data set 5, 8, 10, 12, and 15, we want to find the mean deviation about the mean. First, calculate the mean. Sum all data points 5 plus 8 plus 10 plus 12 plus 15 equals 50. Divide by the number of points, which is 5, so the mean is 10. Next, find the absolute deviations from the mean. For 5, the absolute deviation is 5 minus 10 equals minus 5, absolute value 5. For 8, it's 8 minus 10 equals minus 2, absolute value 2. For 10, 10 minus 10 equals 0. For 12, 12 minus 10 equals 2. For 15, 15 minus 10 equals 5. Add these absolute deviations. 5 plus 2 plus 0 plus 2 plus 5 equals 14. Finally, mean deviation equals total absolute deviation divided by number of points. 14 divided by 5 equals 2.8. So, the average spread of the data points around the mean is 2.8. You can imagine a table showing data points, their deviations, and absolute deviations, helping you keep track step by step. Excellent beta. This example shows how mean deviation quantifies variability simply and clearly. Let's handle a group data example now, where marks are given in classes with frequencies. Step 1 is to find the midpoints, or class marks, for each class interval. These midpoints represent the values x sub I. Then, calculate the mean by summing the product of frequency and class mark for all classes and dividing by the total frequency. Next, determine the absolute deviation of each class mark from the mean. Take x sub I minus mean, then the absolute value. Multiply each absolute deviation by the corresponding frequency f sub I. Add all these products to get the total weighted deviation. Finally, divide this total by the sum of all frequencies to obtain the mean deviation. The formula stands as mean deviation equals sum of frequency times absolute deviation over total frequency. Imagine a frequency table filled with these columns: class marks, frequencies, deviations, absolute deviations, and frequency times absolute deviation. It's a neat way to organize your calculations. This method efficiently summarizes the spread in group data, like test score ranges. Wondering how to compare variability across two very different datasets, maybe from different subjects or tests with different average marks? That's where the coefficient of mean deviation comes in. It's a relative measure that normalizes the mean deviation by the central value. Specifically, the coefficient of mean deviation about the mean is mean deviation divided by the mean. Similarly, the coefficient about the median is mean deviation divided by the median. Because these ratios have no units, they let us compare dispersion even when data units or scales differ. A lower coefficient means less relative spread, indicating more consistent data. Visualize a bar chart with two datasets side by side, showing their mean deviations and mean or median values. This comparison aids understanding which data is more consistent relative to its center. So before concluding which dataset is more variable, consider this relative measure. Let's quickly recap our journey with mean deviation. For ungrouped data, the formula is mean deviation about mean equals 1 over n times the sum of absolute values of x sub I minus x bar. For median-based spread, Mean deviation about median equals 1 over n times the sum of absolute values of x sub I minus m. In group data, mean deviation equals sum over I of frequency times absolute deviation divided by the sum of frequencies. Key takeaways: mean deviation measures spread using absolute differences from a center, either mean or median. It is especially handy when data is skewed or contains outliers, as mean deviation about median reduces the effect of extreme values. The coefficient of mean deviation helps us compare dispersion across datasets by standardizing the measure. And when dealing with group data, remember to use class marks and frequencies as your computational foundation. Keep practicing these concepts and calculations, and you'll find mean deviation a valuable statistic for understanding data spread in your studies and exams. Shabash! Keep up the great work.